In this video, I will explain each of the model specification settings for the HeatSeeker 3.0 and we'll go through how to add your own. As you look through these variables, note that all units are in SI units unless stated otherwise. Temperature is in Kelvin. MS mode. This tells the program whether you would like to save the model specifications to a file or load them from a saved file. Load is useful when you do not have access to the M file to make adjustments directly. Overrides. These are set to 1 or 0 depending on whether you do or do not have certain extensions to MATLAB installed on your machine. Model type. This can either be transient or steady state. The transient model type is currently untested, so it's best that you leave this one alone. RM. This stands for reduced model size. It only runs the upper left quadrant of a 3D model. This is used to cut down on processing time. Boundary conditions. The interior wall is the side that does not have the foam square on it. Remember that temperature is always in Kelvin. Mesh settings. The model uses finite element analysis to reach its conclusions. Hmax is the largest distance between corner nodes that you are willing to accept. It is extremely important to note that your mesh size is not the actual distance between each node, as MATLAB places a node at the bisector of the line between corner mesh points as well. This means that the number of nodes will be higher than what you would expect. NCM 3D. You can request that the mesh be inconsistent across the 3D model, so that the model is more precise only at points of important analysis. This greatly improves the solve rate of the 3D model. Foam modification settings. These dictate how the length, width, and height of the model will be adjusted so that different foam squares can be analyzed. This feature is not necessary for the average user to understand. HSHF. The heat flux scale factor scales heat flux errors for plotting so that they don't shoot way off the screen and that their direction is properly visible. PN. This is the number of points that will be plotted for processes like plot temperature across the intersection. Parpool. This setting asks whether you would like the computer to use every single core at its disposal or the number of cores the system prefers. I do not recommend that you touch this setting unless you really know what you're doing. From here on, any settings that you see can be overwritten by presets, which will be covered in the next video. Property style. This tells the computer what way you would like to apply the thermal conductivities if varying thermal conductivity is requested. I will go into further detail on property styles in a future video. Geometry shape. Standard is for the geometry to include the foam protrusion. Rectangular is to remove the foam protrusion. The rectangular style can be useful when analyzing heat flux on the surface. Shape of objects. The properties of specific objects on the wall are given in the following format. First, the name of the object is given, either foam, wall, plate, for the metal plate in between the foam and the wall, and stud for studs. Thickness is given in the X direction, length in the Y direction, and height in the Z direction, which only applies to the model in 3D. Tc is the thermal conductivity of the object. R is the R value that the model expects the object to have. The R value does not control the thermal conductivity that the program uses when evaluating the model. It is only used for the final comparison between expected R value we give it in this section and the R value that the model predicts. The R and Tc must be edited separately, and it is your responsibility to make sure that they match. If you intend to add your own MSD, I recommend that you follow the similar format that I used. You will need to add a section where the model specifications are translated into a format that the program will use. This is done in section 101 of pre-run. For example, the thickness of the foam is translated into a single variable, TF. The code will then reference the variable TF for all future processes. This is done so that the original values that you specified using MSD system is not overwritten if the program needs to, say, modify the thickness of the foam for whatever reason. This should be all you need to know about the model specifications. In the next video, I will discuss how to save and call different model specifications using presets.